It's June 3rd, 2022. I'm Todd Dunn, and today I'm over at the marina, just about to go aboard my 1972 Allied Princess Sequester. However, I'm not going out, and here's why. You'll notice the water is flat calm. There's not a breath of wind today. Good weather for motoring around, but that's not really what I want to do today. In addition, the fog only lifted out about an hour ago. It was socked in, and it's supposed to come back in this afternoon later. So anyway, what I'm going to do is go aboard the boat, and we're going to talk about the fuel system on an old fiberglass sailboat that you might be looking to buy. So let's go aboard. Okay, why do you want to be concerned about the fuel system on an old fiberglass sailboat that you might be looking to buy? Well, the reasons are some of the components in that fuel system may be worn out and need replacement. And some of those components, in particular the fuel tank, may be very difficult to replace. And difficult on an old fiberglass sailboat usually means expensive. So you want to know what to look for in a fuel system. So what I'm going to do today is talk about what the primary components of a fuel system are and what components you need to be concerned about and why. It's all pretty simple. Okay, what is the primary component in a marine fuel system? Before I go into this, I'm going to restrict myself to old fiberglass sailboats that have diesel engines, and there's a reason for that. Gas engine systems are much more tightly restricted, but fortunately there are not a lot of larger sailboats that have gasoline engines. So the vast majority of fuel systems that you're going to see on an old fiberglass sailboat are for a diesel engine. So what are the components? Component one is a fuel tank. Fuel tanks are made out of a number of different materials. There's nothing wrong with any of these materials, but they all have different considerations that you need to be aware of connected with them. Now, on a really old fiberglass sailboat, you might find that the fuel tank is made out of copper or maybe Manel. Manel is a copper nickel alloy. Now, if you have a copper tank, well, obviously, if there are leaks dripping on the copper tank, you're going to probably find that there are spots of green corrosion on the tank. And you can indeed, if the tank is sufficiently corroded, have it corrode right through. That said, copper tanks are generally pretty good tanks. They're non-flammable. I mean, they're non-sparking. If you hit them with another piece of metal, it won't spark. But they are pretty soft, and it is possible, if you make the wrong mistake, to punch a hole in one, which is not a good thing. However, there's nothing intrinsically wrong with copper tanks as long as they are located in the boat in a location where they stay dry and won't come in contact with bilge water, which might be salt water, or rainwater, which could cause corrosion in the tank. So if you find that you have a copper tank, now this isn't very common, but it might be on, say, an early 60s boat, nothing wrong with that. Just inspect it to make sure it's in good shape and that it isn't up against any other metals, because copper will react where it's in contact with other metals, and that can cause very significant corrosion. A Manel tank is the next one that you might find in a really old, say late 50s, early 60s vintage boat. If you find a Manel tank, although it generally means that the boat was a high quality boat, because Manel is and was a very expensive metal. Now, the advantage of Manel is that it's a very sturdy metal, and it is, of the various copper nickel alloys, probably the most noble of them. In other words, it's highly unlikely that a 60-year-old Manel tank will have any corrosion on it. It'll probably, if you open it up and clean it out, look brand new. So Manel tank is a really good thing to find, but except for the boats that were really expensive when they were built, very high-end boats, you're highly unlikely to find one, simply because Manel was and remains very, very expensive. But if you do have one, it's a good thing, and you should be quite pleased with finding that the boat has a Manel fuel tank, because a Manel tank can sit in bilge water for 50 years and not have any significant corrosion. It's basically the best possible material for a fuel tank. And if it's a well-made fuel tank, it'll have internal baffles and basically is the ideal. But as I said, with the exception of a few very high-end boats, you're not going to find a Manel tank. Now, in an old boat like this one, this Allied is 50 years old this year, or an older boat from the 60s, somewhere in the 50 to 60-year-old range, it's quite common to find fuel tanks made out of steel of some sort or black iron. Now, the tankage on this boat was a black iron tank, and it was very corroded when I bought the boat, to the point where the previous owner had abandoned it. But if you have either a steel or an iron tank, you're going to want to inspect it very carefully, both outside, and you want to see all surfaces on it, top, sides, bottom, and you'd also hopefully be able to open up an inspection port and look inside, because any water or moisture that gets inside a steel or black iron tank will cause rust. So, and it's not uncommon with old steel or black iron tanks to have the metal, particularly on top, if water's been dripping on it, badly rusted, and there may well be pinholes everywhere, even though the tank is still in use. And it's also very common with that kind of tank where it's mounted. If the mounts are not dry, if any water has accumulated there, that you will have rust on the bottom of the tank. And if you go to move the tank, you may find that you end up with a very badly leaking tank. And consequently, on a boat the age of my Allied here, an original steel or black iron tank is probably something that you're going to want to think very seriously about replacing fairly quickly, because the chance that it is pristine is very, very small. And that's something you should consider when you're putting in your offer. And bear in mind, not all tanks are easy to replace. For example, on my Allied, I'm using it as an example because it's here and I'm very knowledgeable about it. The tank was located under the engine. And in fact, the top of the 40-gallon black iron fuel tank made up the bottom of the bilge. And there was, when I bought the boat, always water on top of that tank. And it was very, very badly corroded. Now, the problem with it was put in before they put the engine beds in. And the engine beds were on top of the outer edges of the tank. And the tank, as I said, was under the engine. So to replace that tank, you had to pull the engine, cut away, either cut the tank up into pieces and pull it out from under the outer edges of the engine beds, and then somehow reinforce the engine beds, or do what the previous owner of my boat did, simply leave it there and cap it off and install another tank. Now, I did remove the tank. It was a huge and very nasty job because it had corroded through in a number of places and bilge water had filled it up. And I can tell you that bilge water that's been in a tank for 30 years is not very pleasant to deal with. And it took a lot of effort to cut that tank up and get it out of that area. And we did it while the engine was out of the boat. Wouldn't have been possible with the engine in the boat. So that is, tanks can be a huge job to replace simply because of where the builder put them. And if you have a steel tank that's in a very difficult to get to location, it could cost a lot of time and money to get it out of the boat. And then you'll probably want to look for a different location for the new tank. Now, what are other materials for tanks? Well, another type of material that's fairly common on replacement tanks, if your boat has had new tanks put in, is polyethylene. A lot of people use polyethylene tanks because, one, they're relatively inexpensive, they won't leak. They're fairly thick polyethylene, around 1/4 inch thick usually, for you metric people, 6 millimeters. And they're reasonably sturdy, and they will not corrode because, of course, they're made out of plastic. Now, the downside of them is they're not very strong. And when you fill them up with fuel, they will bulge if they're not properly supported. So they need to be supported on the full support along the bottom and on the sides to have them maintain their shape and not bulge and deform over time. And they also need to be protected from exposure to sunlight. In other words, they need to be in a part of the boat that is dark, because sunlight is the bane of most plastics. Over time, years, they will, if exposed to the sun, get brittle and crack. And that's the last thing you want to have happen to a fuel tank. So polyethylene is a good choice for a replacement tank if you have a good place to put it, where you can build an enclosure that the tank just fits into and it supports the tank well and the tank is not exposed to sunlight. The other downside of polyethylene tanks is that they are just a single tank. They do not have what are called baffles inside. Now, baffles are pieces of the tank wall material that are attached across the body of the tank. There may be 1, 2, 3. How many depends on how big the tank is. And they have perforations in them so fuel can flow through them. But their purpose, though, is that when the tank is moving, say the boat is pitching, the fuel will slosh back and forth in a tank without baffles. And baffles are there to prevent that by greatly reducing the ability of the fuel to move suddenly as a body from one end of the tank to the other. And the reason to do that is twofold. One, diesel fuel weighs about 7 pounds per gallon. So if you slosh it back and forth, let's say you have a 50-gallon tank and it has 35 gallons of fuel in it, that's about 245 pounds of fuel sloshing back and forth in the tank, and that fuel is going to slam into the ends of the tank, and over time those impacts, although they're just liquid, but they still have momentum, and that can damage the tank and cause a failure. So that you'd like to prevent that, and baffles will prevent that. The other reason is with diesel tanks, sometimes you'll get a bad batch of diesel that's got a little water in it. That water will precipitate out at the bottom of the tank, and if there are any microbes in the algae, for example, in the diesel fuel or able to get into the tank in any way, they like to grow at the water fuel interface. and they will precipitate materials out that will accumulate on the bottom of the tank. If you slosh the fuel around in the tank, you'll mix those precipitates up into the fuel, and those precipitates will then go into your fuel system, and they can plug up your fuel filters or your fuel injectors and shut your engine off. And for some reason, dirty fuel clogging filters and fuel injectors and damaging fuel injection pumps always seems to happen at the worst possible time. So that's something you'd like to eliminate if you can, or at least minimize. But you are always going to get a little bit of moisture in your fuel, so you're going to have some water precipitating out. You will get air into the tank, and that will lead to algal growth at the fuel-water interface and precipitation of dead algae and other waste materials down to the bottom of the tank, forming a sludge. Okay, there are a couple of other materials that are commonly used for tanks now. One is aluminum. Now, aluminum is a great material for tanks. You do have to find a good welder who can weld up the aluminum tank. And it's got the advantage that it's lighter than steel, a little bit heavier perhaps than a plastic or polyethylene tank, but it's a good material. The only issue it has is that aluminum is susceptible to corrosion, particularly if you have fittings in contact with the tank that are made of other metals. And if you have a little salt water dripping on top of your tank, that will cause corrosion. And where the fittings go in, the corrosion will be the worst if the fittings are different metals. And that can cause a tank to fail. So another thing with aluminum tanks is they don't like to be in contact with wood, particularly oak. So if you have, say, oak supports underneath your tank, you want to make sure that there are sheets of rubber between all of the wood and the tank, so that the tank is not in contact with the acids from the wood, because they will attack the tank and corrode right through it over time. Don't ask me how I know this. And finally, another common material is stainless steel. And you might think that's a perfect material for fuel tankage. It is a very good material for fuel tankage. The downside of stainless steel is it's expensive. The metal itself is expensive, and you need a fairly skilled welder to weld up a fuel tank and weld all the fittings into it, and that costs money. Stainless tanks are very expensive, and stainless tanks are not immune from corrosion, particularly if they are in places in the boat where they're wet all the time without any oxygen getting in there. You can have what's called crevice corrosion, and that stainless tank can fail in those places. So that's another material. I would say that if you're going to have permanently installed tanks, stainless steel or aluminum is a good choice. Polyethylene, if the tanks are relatively small, say 20 gallons or less, is an excellent choice if it's properly supported. And another possibility you'll find on some boats is fiberglass tanks. Fiberglass is basically a glass reinforced plastic, and it makes excellent tanks. You can even build them yourself. And some boats have integral fiberglass tanks, where the hull of the boat is one part of the tank and then the rest of it is attached to the hull with fiberglass. The only downside of integral tanks is if they get really crudded up and dirty inside, they can be difficult to clean, and you can't remove them because the hull is part of the tank. You can cut away the other parts of it, but you'll still have the hull that you'd have to then clean. And believe me, diesel fuel has a fairly cloying odor, and it's quite difficult to get out of the boat. Okay, that's tank material. When you're buying an old fiberglass sailboat, make sure you know where the fuel tanks are, what they're made of, and what condition they're in. Make sure you inspect them thoroughly. Now, what about getting the fuel into the tanks and then from the tanks to the engine? Well, there will be a fuel fill on top of the tank. Usually that's just a port that sticks up, and there usually be a 1.5 inch or larger diameter hose attached to that that goes up to a deck fill mounted in the deck. Now bear in mind that the deck fill penetrates the deck, and if it's not properly caulked, provides a place for water to leak in and run down that hose onto the top of your tank. And leaking deck fills are a common place for water to get in to the boat and get onto the tanks and cause corrosion of a metal tank. So if you want to make sure that if you do have that your deck fills are properly bedded to the deck and aren't leaking. So you want to inspect them and make sure that there's no sign of leaking around the deck fill on the tank. Now, that hose that goes from the deck fill to the tank can't be just any old hose. If you're in the United States, that hose has to be United States Coast Guard A2 fuel hose, a specific grade of fuel hose that's used for deck fills and for vents on tanks. So that brings me to the vent. If you have a tank and you just open the deck fill and go to pour fuel into it, that tank is, if it's empty, is full of air. That air has to come out somehow, or it's going to make, you're either going to have it burp out of the tank as you fill it, or preferably you need a vent on the top of the tank connected to with a USCG A2 fuel hose to a vent somewhere outside the boat. And ideally this vent should be above the deck. On a sailboat, you don't want it necessarily on the hull anywhere, except possibly in the transom, because heeling the sailboat over in big winds could, if the vent is located on the side of the hull, put that vent underwater, and you don't want that because that water would then flow into the fuel tank. So you want it located on the deck. For example, here on Tortuga, the fuel tank vent is located on the cockpit coaming on the outside of the coaming, about 4 inches above deck level. And it's not in a place where a wave running back along the side of the boat could splash up to it. So you need a vent in the right place, and you want to make sure that that vent is not plugged. Some insects like to plug those vents up. So because if the vent is plugged, when that fuel fill is closed and you're trying to draw fuel out, you will very quickly create a partial vacuum in the tank, and you won't be able to draw any more fuel out. And if you do have a super powerful pump pulling that fuel out, well, the tank is going to have to then be strong enough to withstand air pressure of 14.7 pounds per square inch, or 1 kilogram per square centimeter. And that is a lot of force on the top of a tank and can easily crush a fuel tank if you draw enough of a vacuum inside the tank. So the vent is there to allow you to fill the tank and to allow you to withdraw fuel from the tank. So as you pull fuel out, air will come in through the vent into the tank. And this is one of the sources of water in your fuel, particularly if you're in a very humid environment, that air will have water vapor in it, and that will become in contact with your fuel, and some of it will dissolve into the fuel. but you can't avoid that, unfortunately. Okay, what about the hoses or piping that goes from the tank to the engine? Most commonly, it's going to be a rubber hose, and it is also going to, in the United States, need to be a fuel rated hose, and on a boat it needs to be United States Coast Guard A1 grade hose. Automotive fuel hoses, while they'll work fine, don't meet the Coast Guard requirements, and it's probably not going to cause you a huge problem unless you have to get your boat surveyed, because that is one of the things the surveyor will look for. Do your hoses meet U.S. Coast Guard requirements? And if you've got automotive grade fuel hoses, you'll fail the survey and have to replace them, which, depending on how far the fuel tank is from the engine, can be quite an unpleasant task. Okay, so another thing that you need at the tank where the hose to the engine goes, ideally, is a shutoff valve of some sort, so that if you need to, you can turn the fuel off at the tank, and that way a leaking hose won't drain the fuel into the bilge on your boat. So that's the tank and the connections to it. You have your tank, you have a fill, you have a withdrawal hose that goes to the engine, you have a return hose that also has to be U.S. Coast Guard A1 rated hose coming from the engine back to the tank, and you have a vent hose. So 4 holes in the top of your fuel tank. Okay, what else is there? Well, in most systems, there will be what's called a primary fuel filter between the fuel tank and the engine. One of the most common ones for up to around 50 or 60 foot sailboats is a Raycor 500 series fuel filter. Now, these fuel filters have one big advantage over a lot of others, in that they do also trap water. They take water out of the fuel, and there will always be some water in your fuel, and separate the water out of the fuel and collect it. Now, there are several different types of these fuel filters. The kind that I prefer is a Raycor 500 MA series fuel filter, and this is a picture of one. And you can see the upper part of the fuel filter is a metal canister, and then down below there is a thick plastic bowl with what's called a turbine mechanism, which works to separate water out of the fuel, and the water then accumulates at the bottom of the plastic bowl. And this particular type, the 500 MA, also has a metal bowl on the outside of the plastic bowl, and that is a flame detector. But if your boat is inspected by the Coast Guard for carrying passengers, then you do have to have a flame deflector on your fuel filter, so that if you have a fire in the boat, it will keep the filter from melting for a certain amount of time and allow you time to get off the boat or put the fire out. Now, there's also another type of fuel filter called a Raycor 500 FP, which is just like the 500 MA, but it doesn't have the metal flame deflector on the bottom. Now, those are acceptable to use as long as the fuel filter is outside the engine room. So if it's separated from the engine room by a ways, you can use those even on an inspected boat. Now, I said, what if your boat isn't inspected? It's just a recreational boat. Well, unfortunately, a lot of insurance companies like to apply the inspected boat rules to all the boats they insure. So if you have your fuel filter in the engine compartment, they're going to want to see a flame deflector on that fuel filter. And believe me, I had that happened to me first time this boat was surveyed after I bought it. That's one of the things that the insurance adjuster flagged and told me you have to put a fuel filter with a flame deflector on it if you're going to keep it there in the engine room. So that's a consideration. Now that fuel filter ideally probably needs to have another valve near it so that you can shut the fuel to the filter off when you go to change the filter element in it without having to go all the way up to the tank to close the tank valve. And the hose that goes from the fuel filter to the engine needs to be U.S. Coast Guard A1 fuel hose. So those are the things you want to look for in a fuel system. Now, another consideration when you're buying an old fiberglass boat, if the boat's been sitting around for a while with fuel in it, you can pretty much bet that there will be water accumulated in the fuel tank underneath the fuel, and that probably there will be algae growing at the water-fuel interface, and that the fuel will have a lot of sediment in it. And the fuel will probably run the engine fine unless you get into choppy conditions and mix it all up and get that sediment coming out with the fuel. That will very quickly plug up your fuel filters and shut your engine down. So that's something to consider. You might want to look into removing any fuel in the tank of a boat that's been sitting around for a long time and cleaning the tank out. And to facilitate cleaning a tank, ideally you'd like to have a nice inspection port in the top of the tank that you can actually get to. I've seen lots of fuel tanks with inspection ports that after a great deal of struggling you could open up, and then you could maybe stick a camera in there and take a picture of it, but you couldn't actually look into it. So old fuel can be problematic, and you need to be aware that if you have old fuel, and I'm talking fuel that's several years old, you probably want to get rid of it and clean that tank out thoroughly to get rid of any sediment that's in the tank, because rough conditions can mix that sediment right back into the fuel. Okay, that's what I wanted to say about fuel systems and a little bit about some of the potential issues that you need to look for when you're buying an old fiberglass sailboat with a diesel engine. Okay. Thanks for watching. If you found this informative, please give me a thumbs up. And if you haven't, why don't you consider subscribing to my channel so you'll get a notification when my next exciting video is posted.